Hi, I and a few other World War II airsofters are running a game, Mont La Defense or Devil's Brigade in August 2013. Now, basically we've been going through various scenarios that we're going to use over the weekend. It's a 2-day event. Now, it's basically there's various things I'm making sure which are running. Now, one of the things is we're going to be using the anti-tank gun. Now that's going to be in use by the Germans, as is the tank. So both of these are going to be actually on the Mont La Defense hill, as we have at the X site in Wales. So the tank's going to be marked up again with the Balkan cross, which just fits over the white star. The gun, you've seen demos of it, it runs on propane gas. And it's also occurred to us that we could do with an extra item which we're going to put into play, and that's actually an Enigma machine. Okay, as you all know, now the Enigma coding machine was developed, was it by the Swiss or a Dutchman? I think it was. It was a Dutch company that put them on sale just before the war. I did see one documentary and it said the thing was invented by a German at the end of World War I, but I don't really know how true that is. I'm not going to go into looking up too much detail on this, but essentially that is the Enigma machine that most of you know. Basically it has a series of rotors at the back which gave different wiring combinations according to how you set the rotors, and each time you actually pushed one of the keys, the rotors would turn. Very similar to the stepping of a mileage rotor on an old-fashioned car dashboard. You know how it has little wheels, and once it gets to 0 it trips the next wheel over to another position. But these rotors had more positions on than just 10 for numbers. They obviously had the alphabet worked all the way through the rotors. Anyway, each time you pushed an L, it would click the rotor on. So say you pushed L once and J lit up. If you pushed L again, then S might light up the second time, because the rotors would keep stepping, and the wiring was all sorts of different combinations. And before they actually set it up, you had a section under here which was a plug board, and that gave you another run of settings that you could select. Basically the plug board altered the wiring again that was on the rotors. Now I'm not going to go into this too much, but the basic function of the thing was you'd do all this, you'd set the rotors up, then you'd type the message that you want to send, and as you pushed L, say J would light up, then you would write down J, then you'd push M and W might light up, so you'd write down W. Now you then have to send L and W as Morse code out on whatever means you're using over the radio. so that was quite a laborious way to work. Now I believe later on they went into better machines and they came up with things which used the teleprinter system. Now teleprinters have been around for a good few years before World War II, since possibly before the 1920s. Now basically the teleprinter would speed things up so that you wouldn't have to keep writing out what you'd encoded into another set of letters and then have to type it over into Morse. So they came up with machines called the Lorenz, which used the teleprinter system, and then they did some coding over the teleprinter code. Now, as far as I can remember, a teleprinter used a punched paper tape. Now you could have a reader of that punched paper tape which would read that tape at a faster speed and then send that off down the line or over radio. Now basically I've decided, as this machine here is well, I say quite complicated, but main things are the wooden casing and these keys. Now I've been looking at trying to think how to make these keys. The initial thoughts were, well, you could use very large nails, but then it's going to look pretty naff, isn't it, with just nails hammered into something, and they're not going to look straight unless you take a lot of care hammering them in. And then you're really going to want to put some letters up on tops of these things and try and make them look nice. So you start to get into a lot of time wasted trying to make the keys. Your other things is you've got all these lights, you know, that when you push Y, as I say, a light lights up and encodes it over to a D. Then you've got these rotors you've got to make, and ideally you'd probably want them to spin. Now I'm not saying I'm going to be making this machine so that it'll work, not by any means. That's a hell of a achievement, trying to make a thing work, and I haven't got the time for it. So I was looking around, what could I use? I thought, well, I could just get an old typewriter and just make a cover over the top of it and say, yeah, it's an Enigma, it's a cipher machine, you know. So I went looking around, and there's another version, a later Enigma machine. They're still calling it an Enigma machine. It's called the there you go, original German, World War II, SG41 Hitler Mill Cipher Machine. Now these things, they sell for hundreds of thousands of pounds now. But that's your basic machine there, and hey presto, look at that, it's got square keys. So they're looking a lot more like, well, let's see, what do they look like? Hey, they look a bit like a keyboard, don't they? Now, what do you know about keyboard? Look at the state of my keyboard, it's a terrible mess. Anyway, QWERTY keyboard, yeah, QWERTY. Well, German, Quartz. It's a Quartz keyboard, see? The Z is more used in the German language than the Y. So Z is where the Y should be. It's been transposed. See? Y and Z. So now why they have the J in red, I can't quite work out what the importance of that. The rest of the keys are pretty much the way you would expect them to be. Now you also notice there's no numbers in this keypad, and there's no space, there's no return, it's just all the letters. So don't really understand how they did this. How did they put a break between letters? Is it just that they've made some really strange long strip of letters and people just had to work out where the breaks were at the other end? Maybe that's the case, because, well, let's say if you were trying to decode something and you knew there was a break in between those letters, you could work out the size of the word, couldn't you? Potentially. Don't know. You could work out the size of the word, and by that size of the word you could potentially work out what the word was. Anyway, I'm not going to go into that too much. How are we going to make one of these keyboards? Well, I went in my loft and I found an old keyboard. Yeah, all the keys are missing. It's because I started abusing it last night. I've started taking it apart. Now, all screws are out of this. Obviously they're out of it. If we flip this over, come on, fall apart. Come on. There we go. Take the back off. I've already removed this encoding, chip, which well, you'll see where that goes in a moment. Well, basically, I've taken all the screws out of this. The next thing you have is you have a steel plate. Dump that to one side, but it will be used again. Then you have this this plastic sheet with conductive printing on it. Now this conductive printing, basically these are inside the keys, and if you look inside the bottom of the key, inside this rubber, this provides the spring and the connection for each of your keys that you press on your keyboard. See that little black spot in the center? That's actually conductive. It passes electricity. Now when you put that over these like little interlocking C's and you push it down, it connects the two C's together, and that sends a signal off down the various conductive circuitry to this section here. Now that is where that was pressed against it inside the keyboard, and this chip then sends out what was a binary input going into its pins. It converts it into a serial output and sends it off down your line to your plug, PS3 plug that was, wasn't it? Anyway, that's just junk now. It's a shame I can't still use the keyboard, but it's a little bit more work than I'm really prepared to do. I did toy around with trying to intercept some of these points and try and connect wires to the conductive points on it so that I could reuse it, but I think it's just a little bit too much for the time that I've got to spend doing this. Now here are the keys. Now if you look in here, you can actually see that you can take these in and out. See, they've got little plastic sprung clips. Now if you push one of those, if you push those little clips in with pliers, you can push the key out into to the front. This key comes out forwards, and you can reposition them. So basically what I've started doing is, if you look at, there's a particular shape to this. It's very much like a standard keyboard shape. You know, you've got a longer strip at the back, and then it goes slightly shorter to the on the center, and then you've got this strip of letters Y to M, and it finishes a little short there. It's not sort of like, they haven't biased it over to, so it's completely central. If you look at it, it's very much like on a standard keyboard. Q, A, Z, or on the other one would be Y, and then M, L and P. So you've got M, L and P. See, the same sort of spacing. Now what I'm starting to do here is moving all the keys up. Now the reason being, I've moved the Q from where it is here where I've got A now, right? The reason I'm doing this is because the way the plate here mounts on the back of the keypad, it needs 2 screw positions. So one there, and that point there just locks into a hole on the back of the plate, wherever it goes. If I position that, there we go. Yeah, so you basically need that screw fixing in that one and that hole there, so that the plate stays steady on the back of it. Now, so basically what I'm doing is I'm shifting all the keys up one row so that I can still use the mounting holes. So what I'm going to do is I'm going to cut this section of the keyboard out. It's only plastic, so I might just attack it with an angle grinder and see how it looks. Okay, so that's that cut out, and I've also taken the step of blowing this over quickly with some black matte paint, so only roughly. So that basically gives me my tiny little keyboard. Now what's the next step? Well, basically I need to be looking at making this raised section which the keyboard fits inside of. Now you can see the original one, if you look very closely, appeared to work by probably bars which ran in and out through this metal plating below it. Obviously mine's not going to work exactly like that, and you know, what the hell, you know, it is just a replica. Now, so I've got a couple of options here depending on how neat I want this to look. One option is that I make a plate which has a cutout just around the key sections here, yeah. Obviously I had to just attack these with an angle grinder and a pair of side cutters, you know, trim it off with some side cutters. It's done very coarse, rough. Now yeah, so as I say, one option is that I cut a metal plate with just the keys, the key area coming through the plate. Then the other option, if you want it to look really sort of nice and, what's the expression, Gucci, is to actually mark off on the plate a series of holes so that this will actually slide through that metal plate. Now you could just make large round holes which these will fit through, or you could make the holes smaller and file them square, which takes even more time. Okay, if you look at the shape of the keyboard, you see it has this slope, it comes down at the front, pretty much like modern keyboards do, sloping down to the front makes it easier to type. and so on. And then they have this little flange which is flared out at the side with basically a screw going through it, holding it down to the base unit. So I decided that I probably need to do something along that shape. Okay, I've gone for the slightly Gucci option. I made a few mistakes while I was marking the metal out over at that end, but yeah, I've drilled a load of holes and finished it off with the old square drill. So the next thing to do is to mount this between two pieces of angle in my vise and start folding the sides up. Always work along it slowly and progressively from one end to the other. Never do one end and then do the other end, because you stretch the metal and you'll end up with a curve in it by the time you folded it over. Then you fold your ends. Notice I've left a little bit of a tab at the end here. That's basically to be folded over and probably welded to the folded side when it's finished. Once it's all folded, it should look pretty much like that. Now you'll see here the slight angle I've put on it. See, I've made the front of this 15mm and I've made the back 20mm high. And these are the two flanges here which need to be drilled to mount it down on the casing. Yeah, so how I'm going to fix this up inside there, I'm not sure. I might just put some epoxy on the thing or hot glue. I might work out some way of putting some screws in. Don't really know at the moment, but the thing's not really going to be getting stripped down, or at least I wouldn't think I'm going to need to take the actual top keyboard section out, this piece out again, once I've fixed it into the metal. Obviously I've got to make sure that the metal's all painted up, primed and painted before I put all the keys back in. Don't want to do it twice, do I? Okay, that leaves us with that once it's done. I've mounted the section of steel off the back of the keyboard back in. As I said before, it has a couple of screws and a little locating tab. Now I've also cut a piece of the plastic conductive strip that was in the keyboard. As I was going to throw it in the bin, I thought, well, I may as well, just in case at some time in the future I come up with an idea of trying to wire the keys up. I've left a piece of that plastic in there, and there might be some way I can attach some wires at a later date. So come on, Stella. Yeah, okay, so see, the keys work alright, as you'd expect. So that's my little quartz keypad. Now, in terms of the rest of the unit, I'm just not sure. Come on, out of the way. I'm just not sure if I'm going to have the time to make all this up, because I've got a lot going on. Now, what I have got as a fallback is this is a bit of scrap. It's a power distribution panel, which is a bit of junk that's a number of these kicking around in my job at the moment. People ditching them in corners of exchanges, and I'm actually recovering a few of these myself. So I'll be generally getting rid of them. Now what I could do is I could mount all this on as a quick fix, a quick way of doing this, I could take all this stuff off the top of the panel of this box and just put a blanking plate on the top, get rid of all these sockets and switches, and put whatever holes I want in it. Or I could be really naff and just spray the whole thing black with the switches and things all sticking out of it. That's a big isolation switch. Anyway, yeah, so I could just mount this whole thing, screw all this down onto a big heavy piece of plywood, and spray the whole thing black, and put a big sort of windy handle sticking out the side of it. It would be crude, but it would get the job done, wouldn't it? At least it's got a keypad on it. Right, I decided to print off a picture of the SG41 so that I had something to work with out in the garage. And so what I've done is I have mounted the case down on 2 sheets of 18mm plywood, and I've made a new top for it, a little edge folded over at the back there. That's just going to fit on. I've tried to cut holes in the top which approximately duplicate the ones on the original machine, and the only thing I haven't decided on is whether to go a little bit crazy and try and do this part. You see, this part's recessed in where the rotors fit. I might just put a flapped screen above the rotors. I'm not going to put rotors in there, I don't think. If I do put any in, they're just going to be pretty much dummy ones. But there's no real point. All I need is numbers below a screen, so why go to the trouble of making rotors? There's no real point in it. So yeah, so because this has this cranking handle on the side, I thought I've got to do something. If I'm putting a cranking handle on, it should be doing something, shouldn't it? Even if it's got nothing to do with the Enigma machine, with its normal function. If I'm putting a cranking handle, it should have some function. So we ditch that lid. What I've actually put is, you might have seen this in a previous video where I was discussing making a small explosive igniter, you know, one of those hand cranked detonators. Basically it's a small dynamo, this, and I've put a piece of stainless steel bar on it, and I've used a piece of rubber hose pipe with split pins running through as the connection point. Basically this unscrews here. See, there's a very short piece of imperial thread which comes out of these little dynamos, and I've basically welded a nut onto a bolt, onto an M8 bolt, and I've pushed it into a piece of rubber pipe, and then I've just drilled right through the pipe and the bolt and put a split pin through. The reason I've done this is because my welding on that nut is not absolute precision, so it's basically a flexible coupling which I've made. It doesn't have to take a lot of force, so it should do its job quite well. And then here I've just put a piece of stainless steel bar in and drilled through the other side, so in the middle it's just a piece of flexible rubber piping. They're quite rigid, those pieces of piping, so just does the job. So I've just got to attach a cranking handle on the end here. Now I found this was lying around in the garage from when I did the elevation mechanism on my M3 anti-tank gun. So I can use this cranking handle. It's not identical to the World War II one. You can just about see part of it there, but it probably was a hard plastic or Bakelite, and there's a good chance that this is fairly old as well. It's probably dates back to the 1960s, if not earlier. It came off an old jack, hand crank jack. So the way these hand cranks fold is quite clever actually, because when it's in its stowed position, it sits in that position there. It swings round in front of the keyboard. So you think, well, how can that be? If you were to swing that round, if you get a position of this, if you were to swing that round from that pivot point there, so it came round like that, you wouldn't be able to rotate that because it would hit the desk below it. See what I mean? So what they actually do is they have a metal plate which runs across about that far, and it has a hinge on it about there. So what happens is, let's try and get this right. When this is folded over like that, the hinge on this part is coming forward that way, so that folds around like that. But when you actually want to hand crank it, the hinge is here where my little finger is, so that swings back over the top of itself, and it changes the pivot point so that you can swing it down and crank the handle, if that makes sense. Yeah, I'm going to try and see if I can make one of those. I probably shouldn't really be going to all this trouble, but it's sort of when you start doing, or when I start doing things like this, I tend to start to get a bit carried away and continue with it. Now this hand crank, these put out about what was it, about 80 volts AC when you crank them. So you might have seen my electric chair video where basically I'm using one of these. These were inside field phones basically, so the hand crank on a field phone is similar, has a similar unit to this inside it, and you get a decent belt off it when it's cranked. So what I'm probably going to do is, when I've finished this, I'm going to put 2 screw terminals up at the back, you know, like on a power supply, or on a field telephone in fact, so you can put 2 wires into it. So what we could have with this is, well, obviously I could use it for electrocuting people, but just for the hell of it, it's a dual usage prop basically. But what I can do with it is, once I've got 2 screw terminals on there, I could just have this as a signalling system. So basically if you crank the handle, it makes a bell ring at the other end along a long length of wire. So let's say, for instance, if I was running an airsoft game, World War II airsoft game, and we had the someone had to send a coded message from the Enigma machine, well, let's just say by hand cranking it you would actually get an output from it which would send some sort of signal to the other end. If nothing more elaborate than that, at least it will have some sort of function when you crank the handle over. The other option is that I have some sort of hand crank on here, which it's going to have, and I eventually put some sort of like little electric motor in here so that it would spin a motor and maybe output some printer paper out the top by cranking this. But you know, this could have all been done directly, couldn't it? I could have just had a hand crank here and then a pulley over to it, and the pulley could have just basically pumped the paper out the back, and the paper could be pre-printed with a message on it so that it sends that message out the back when you crank the handle. Anyway, they're just little ideas I've been thinking. At the end of the day, the main purpose of this is it's just a prop to get lugged around in a game, so you know, it doesn't really have to do any function at all at the moment anyway. So I think it's starting to look quite good. Most of this I did in one day, but once I got to the top, I didn't like using the original lid off the case, so I thought I'm gonna have to make my own. So I cut some scrap steel up, and that's what I've got. I think it's coming on reasonably well. The other thing is this this unit, the SG41, it wasn't like a teleprinter as I was actually thinking. The way it functioned was you would basically type your message, the quick brown fox jumped over the lazy dog, yeah, whatever. You'd type that in, and what it would do is it would actually print out the coded version of it as you typed. The coded version would come out on paper like a printer. So rather than on the as with the early Enigma, it illuminated a light bulb, they've done away with the light bulbs. So by using this, the coding comes straight out, done on a piece of paper. You rip that piece of paper off and you give it to the guy to send off on the Morse code key. So that basically cuts out a whole stage of labour having to write out onto a piece of paper. It automatically comes out on the printer. Now, when you receive a coded message from the other end, and you've got it written down on your piece of paper all in gibberish, you basically type that in on the machine and it will print out the translated one in a long line of text, I presume, coming out on the back. So there again, it speeded up the process compared to the old Enigma box. The old system just didn't do that, so it would have been so much slower.